Hi, and welcome to the videos for Chapter 2. We're starting with Section 2.1, which is the chapter on derivatives and rate of change. Specifically, we're going to use derivatives, the idea of derivatives, to find slope of a tangent line, instantaneous velocity, instantaneous rate of change. The first topic, tangent lines. So if you've ever had me as an instructor, or if you've been watching these videos, you know that I'm not big into the derivation of formulas. So for example, the quadratic formula. I don't go through how we can use completing the square and that idea to eventually derive the quadratic formula. In those classes, it's kind of sort of above that. With this one, again, I don't want to waste a lot of time on the videos going through the derivation of it. However, on pages 73 through 75, so 2 pages worth, it'll actually go through how do we get the formula that we're going to be using here shortly. That being said, I don't want to just jump right to the formula and say, here's what we're going to be using. I want to explain it a little bit. So if, let's say we had the equation y equals x squared. So that's what? That's the parabola, right? And in the past, you might have had a problem that said, find the slope of the tangent line to the parabola that goes through the point 1, 1. And then it would have given us some other point. And then once we had that other point, what could we do? We could use the slope formula to find the slope of that line, and then use the point slope formula once we had the slope using the point that we're given, in this case 1, 1, let's say. But now, in calculus, we're just going to be told what is the slope of this line and eventually what is the equation of the tangent line through this point. So it only gives us the one point. It says, here we go, it's touching the parabola. What's the slope of this line? So the idea is that what? Let's say I was given some point over here. Well, obviously, if I'm given this point, using the slope formula, y1 minus y2, y2 minus y1, x2 minus x1, I could find out the slope of this one. As this point moves around the parabola, I get a different line. And as it moves closer and closer to this point, I get another line. And what happens when those 2 points are almost the exact same point? So, for example, in terms of our limit talk, as our value for x, so let's say that this is our point A, the one we are given. So if A is 1, if this is our value for x, and then this is our value for x, and as x what? As x approaches A, so when they become essentially the same thing, what happens? We get basically that line, but now we have 2 points, although they're moving closer and closer to each other. Once we have that, then we can use the point slope formula. So, graphically in another way, and how we actually will derive this formula, let's say I have some function, f of x. And, actually let me draw this a little better. A little more angle better. There we go. So let's say that at this point here, let's call this a. So if this is my function, f of x, this point a, the point on the graph here, would be equivalent to what? F of a. So if it's x squared, then I would just plug in that value, figure out what it is. If I choose some other point here, let's call this x, then this point here would be what? This would be f of x. So take the function, plug in this value, that gives me this point here. So now, this distance is what? Well, it's x minus a. So whatever those two arbitrary values are, if we take the difference, that gives us that space in there. And what do I have here? Well, I've basically created a bit of a triangle, right? So the bottom of this triangle is x minus a. What's the height of the leg of this triangle here? Well, it's this point, which is f of x, and this point here is f of a, so the total height of this side of the triangle is f of x minus f of a. And what does that give us? It gives us rise over run, change in y over change in x, which is what? That is our slope. So that's how we come up with the formula, and definition 1 says that the tangent line to the curve y equals f of x at the point P which has values, so we're calling P this guy here. So P is that point. So if we wanted to know the tangent line at our point P, not very straight, sorry about that. So this red, if that's the tangent line to the function at that point P, which has values what? A and f of a. Is the line through P with slope m. So recall that from Math 126. Pre-calculus, our slope is always given the variable m. So m is the limit as x approaches a. So as x moves closer and closer to a, and this height in the run becomes, almost 0, so it gives us that point, is the formula what? Well, it's the rise over run. So f of x minus f of a all over x minus a. So this is, at least for the moment here, and I'm going to simplify it or redefine it here in a second, but if we want to know the slope of a tangent line, it's the limit as x approaches a of f of x minus f of a all over x minus a. So now let's rewrite this guy. Let's redefine a few things and change it up a little bit. So if we say some variable h is equal to this guy here. So this x minus a, instead of in the denominator, I'm just going to call it some variable h that I'm redefining. So as x goes to a, that means what? That means that as x goes to a, this thing's getting closer and closer. That means what? That means h is going to 0. So if h is equal to x minus a, then using a little algebra, I can say what? So x is equal to, if I want to say x equals what in terms of a and h, well that means I have to add a to this side, add a to the right, to the left side. So that means x is equal to a plus h. And all I did there was I said h is equal to this guy, so that means x, if I move the a over, is a plus h is equal to x. So now I can rewrite definition 1 into what we're going to use much more frequently. Definition 2 says that the slope is the limit as h goes to 0. So the distance between x and a is going to 0. And f of, well what? I had f of x, but I just said that x is equal to a plus h. So this is really f of a plus h minus f of a all over x minus a, which I redefined as h. So this guy here, if you have a cheat sheet, if you have a reference sheet, you have something going for formulas, you really want to have this one marked, highlighted, etc. I'm going to use this a lot. So, now that we've simplified that, let's go back to sort of the original example that we had looked at to open up the video. Let's say I want to find the slope of the tangent line to y equals x squared at the point 1, 1. So that's the picture we started out drawing. So all I want is the slope at this point. I don't necessarily want the equation outline, just the slope. So that means what? It means I'm going to use this formula here. So the slope is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. So what is this f of a plus h and the f of a? Well, think about before, if I had, so this guy is really what? My f of x. So f of x is equal to y is equal to x squared. So f of 2 meant what? Well, it just meant I plugged in 2 anywhere that I had an x variable. Or if I have f of negative 1, well, what happens? I just plug in negative 1 anywhere that I have an x variable. So all f of a plus h means is that anywhere I have an x variable in my function, plug in a plus h. And f of a means anywhere I have an x, just plug in the value a. And the reason we're doing this is because what do we have right now? As h goes to 0, that means what? The denominator is going to 0. And that's a problem for us. But by doing these calculations, plugging in the f of a plus h, f of a, we should be able to factor out an h, which will cancel with the denominator, and then we're just left with a nice clean piece to work with. So let's figure out first f of a plus h. So that means I'm plugging a plus h in for my x, so that's a plus h squared. So that's what? If I FOIL this thing, don't just square both terms and that's it. This is what? A squared plus 2ah plus h squared. And my f of a is what? Well, that's just straightforward. I just plug in an a. So f of a is just a squared. So now let's go ahead and rewrite this. So I have the limit as h goes to 0 of f of a plus h, which is a squared plus 2ah plus h squared minus my f of a, which is a squared, all over h. The very first video that I did for Math 181 was what? What did I tell you guys? I told you that your algebra skills are going to be so critical here, that you need to be super careful with what you're doing as you're distributing, especially when you start dealing with negative signs. And this is really the first case where it's super critical, because some of these problems might take you a whole page of algebra. And if at some point in the process you made one mistake with a negative sign, the entire rest of the page is really just wasted time and wasted work. So in this situation, this one's not too bad, but as these get more and more complicated functions, you got to be ultra careful with how you're distributing negative signs and how you're figuring out quantities squared, things like that. So now if we continue here, what do we have? Limit as h goes to 0. So if I get rid of the parentheses here, from this first part, this is minus a squared, right? So here I have a plus a squared, a minus a squared. Those cancel each other out, so I'm left with 2ah plus h squared over h. So now what? As I was saying, you should be able to factor out an h, which we can. So we have the limit as h goes to 0. Factor out an h in the numerator, you get 2a plus h all over h. So these h's cancel. Come back over here, run out of board space there for you. So we get what? We get the limit as h goes to 0 of 2a plus h. So if we find the limit, well, as h goes to 0, that means what? That means this goes to 0, so we're just left with 2a. So the slope of this thing is 2a evaluated where? At 1, 1. So this, our value for x, is the value of a that I'm trying to evaluate. So if I plug that in, 2 times 1 means that the slope of the tangent line at the point 1, 1 is equal to the value 2. So again, we didn't need another point. We used this idea of limits, went through the calculations, plugged in our value for a, which was x from the point we were given, got slope of 2.
Hi.
Hi, you guys need this room?
Yeah, we have this room reserved.
Okay, no problem.
Okay, thank you.